Hello, everybody. This is Mr. Azad with your chemistry class, and I'm doing a recap video. So since we have a new schedule, instead of posting a video every day after classes end, I figured I'll post a recap video towards the end of the week. Now, I missed out on week 1, so that's what this video is going to be, and week 2 will follow shortly after that. Now, as far as week 1 goes, let's take a look at the Schoology. So as always, your Zoom live session, first link that you see. Follow that with the resources folder, where we have the bell schedule, the link to the YouTube channel, the syllabus for the course, the textbook, or the part of the textbook that we're using right now, as well as a presentation. I took your feedback into consideration, and so a lot of you guys wanted more visual aids, and so where you go with the PowerPoint presentation, you can kind of use to help yourself out. And so if you ever miss a class, if you're confused as to what's happening, you can always use the presentation, the textbook, as well as these videos to kind of get you up to speed. Now, the first day of class, we went through and we did the normal, right? We looked at the agenda. Every week, I will put up the previous week's stuff in its own folder. And so here's the week 1 folder. In it, we'll have the agenda, the pretest we completed, lesson 1, which we finished, and notes on subatomic particles, which we had also finished. Let's take a look at what we did this past week. Let's look at the agenda. Go ahead and click on that. It's fine if we don't follow the agenda directly to the T. I'm very flexible with that. So let's see what we ended up doing. We went through the syllabus. I had you guys sign the syllabus at the end. I had you guys make copies of the evidence notebook. And then we worked on the pretest, which is not listed here. That was something I forgot about. And then we followed up with lesson 1 and then notes on subatomic particles. That took a day. Lesson 1 took a day. Pretest took more or less a day. And so here we are. Close that up. Take a look at the syllabus first, get that out of the way. So if you don't know where to find that, that is right here, course syllabus. Click on that. And let's go ahead and zoom in. So nothing much really changed. I'm going to briefly go by this because I'll only go over the parts that changed since last semester. The learning targets all changed. The first 3 learning targets are about the first unit we cover. Next 3, next unit, last 4, last unit. For a total of 10 learning targets each for the semester. So about 1 learning target per week. Logistics really hasn't changed. One thing that did change is if you want office hours, if you want to meet up after class, just send me an appointment. It's too much of a hassle to just wait for students to pop in after 2:15. So if you want to meet up, we could do that. Just set an appointment. Just message me on, here we have it. Message me through email, Remind, or Schoology. Schoology is probably the best option to get in contact with me. I am on Schoology pretty much all day, but I don't really look at messages until the end of the day or at the beginning of the day. Remind would probably be second best. I do have my phone on me most of the time, but you won't get a message until I'm done with teaching. Email, again, I'm pretty much always on my email, so it's right up there too. So in order, I suppose, Schoology is probably your best bet, followed by Remind, followed by my email. If you need the Remind codes, just text 81010 and then @Azad, whichever period you're in. If you end up being in the wrong period, I'll just remove you until you get back into the correct one. Materials didn't change, attendance policy didn't change. I'm just making it clear. If you can't make your live class for whatever reason, just check in through email, Remind, or Schoology. Elsewise, I will mark you absent and have to contact you somehow. Let's scroll down here. And this is something I'm going to try to do as well. At the end of the week, without a single check-in, I'm going to attempt to call home and I'll attempt to send an email. If I can't do either, I mean, you'll know that I tried. Let's see. You're going to be absent, let me know. Something about this semester that's very different is that I'm fully prepared. And so if you know you're going to be absent on a certain date, contact me and I'll get you the stuff you're going to miss prior. Zoom session etiquette, basically just don't be inappropriate and don't be obnoxious, and I'll ban you. That's the biggest thing here. In chat, which I really like using, no inappropriate comments. It's very straightforward. If you do end up, I don't know, dropping curse words or, I don't know, inappropriate things, let's call it that, you're just gonna be banned from Zoom for a single day. I'll let you back in the next day. But if whatever you miss is whatever you miss, I'm not gonna help you out for your own policy, for your own, what you call, I'm not gonna help you out if you're being a dummy. All right, grading policy, that didn't really change. Evidence notebook, that didn't really change from last semester. Keep it scrolling down. Testing policy, nothing really changed. So just as a single reminder for all of this, we are doing the mastery learning still. And so as far as that's concerned with me, if you end up doing poorly on an assignment, you could always try to be better with it, right? So you got a 1 out of 5, do it, turn it in later, and get yourself a 4 out of 5, right? You can always improve. I figured though I was a little bit too lenient last semester. And so as far as late work is concerned, I'm going to be a little bit more strict with deadlines, especially in a 10-week system. After a due date is done, has passed, you can still turn in late work, but the penalty is just a mild, instead of 5 out of 5, it'll be capped off at a 4 out of 5. If that happens often enough, you'll see your grade being at a C or B, probably even a D. So that's a one change here. Let's see, grading system, work habits, cooperation, don't cheat. Here we go. The tentative schedule for the rest of the year. We are currently talking about the different types of bonds. So I suspect next week, week 3, we'll be getting into this business, the different types of bonds that there are, and our unit assessment is coming up. So far, I am keeping on pace with this tentative schedule, and so expect the rest of it to, follow through. I took your guys' feedback into consideration, and I've chosen to do more labs, essentially 1 every week, more or less. But there are occasionally times where that is just not possible. But we'll try. So, with that said, give this a read through on your own if you haven't already. You already listened to it. And then fill out the form. So if you just click on that, chemistry syllabus sign up. There are maybe like 10 of you guys between all of my classes that haven't yet done this. The penalty for not doing this is I'm not going to grade your work until that is turned into me. And that's that. So cross that out. And look at the agenda. Right. After we had gone through the syllabus, I talked to you guys about your chemistry notebook. So same deal like last time. Let zoom in here. Same deal like last time. I wanted you guys to make your own copy. You guys have mostly done that. And then, share it to my email. My email is, I'll put it up right here. There it is. adibsami.azad@leust.net. So once you have done that, I could now grade your work. After we had done that, I think this stuff was like that first day. The second day was dedicated to the pretest and the start of lesson 1. The pretest was, again, a 15-question multiple choice test with a couple of retries on it, but that retries are just for technical difficulties, like if your computer crashed for whatever reason, which actually did happen to a couple students. This pretest, I really hope you guys took it because you're going to take it again, this time for a grade. And that brings me to the second part here. The unit assessment. The unit assessment is broken up into 2 parts. The first part is retaking that pretest, this time for a grade. But the second part is a little bit more in-depth. The second part of this of your assessment is you alone or with a partner attempting to identify unknown elements based on their different properties. And you're going to get an understanding of these properties as we go through the unit, but that's basically the gist of it. Attached to that half of the assessment is also a short presentation you're going to make on an element of your choice. So you and alone or with a partner. So more information about this stuff will be given out about midway through the unit. So I suspect on Monday or Wednesday week 3. There's that. Vocab, we had already gotten started on a good chunk of it, so most of it's already filled out. We're missing like 5 or so different words. That brings us to lesson 1. Lesson 1 was due this January 22nd, and so that was this past Friday. And so most of us did pretty well on it. We went through it in a class, and I wanted you guys to start off on a high note. And so with this assignment, just going through lesson 1, with this assignment and looking at the presentation here, what we're working with is this idea, like how is it that we could see our bones but not our flesh, right? Why doesn't X-ray work the way it works? That's what we're asking ourselves. And so asking the classes, different classes we have, I came through this final answer here, except that radiation is able to go through both bones and soft tissues. However, X-rays can go through soft tissue, but are absorbed or reflected or deflected really by those bones. And soft tissue atoms aren't as densely packed as the bones, as the bones are. And so this brings us to the next topic here of the different types of elements that exist. We have metals, nonmetals, metalloids, right? And so we have a working definition for these guys. Metals, hard, shiny, really, really, really good conductors of electricity and heat. I mean, there's a reason you don't put forks into the outlets. You could shock yourself. Non-metals are pretty much the opposite of metals. So they're brittle, they're dull. Fix that one. They're dull, and they're pretty bad conductors. Actually, they're pretty decent insulators. Metalloids are that in between. Some of them are hard, some of them are soft, some of them are shiny, some of them are brittle and dull, but mostly they're just decent conductors. And I say decent because they're not excellent, which means you can kind of slow down a electric charge and make a semiconductor out of them. Use them to make microchips. This is something I noticed in a lot of the responses I had gotten back. Give me a second here. We didn't really answer this question, I guess, entirely. So how might the atoms of these types of elements differ from each other? We had different opinions about density. We had opinions about the different numbers of electrons they might have, differences in just weight. So you got to remember that weight and density are different things. And so after this kind of like pre-lab stuff, we went through and looked at a few videos. Links to the videos are located in lesson 1 and also in the presentation itself. And so what we did in this lab, quote unquote, is we looked at how metals react to a acid, hydrochloric acid, reacting with magnesium, zinc, or copper. And we just wanted to see how they react relative to each other. And so in that experiment, in that in those videos we watched, we see that magnesium reacts very rapidly, zinc a little bit slower, and copper not at all. And so answering these questions, we wanted to see how we determined reactivity. And so that something reacts if you see any bubbling, if you see, well, you can't see the gas, but if you could collect the gas, if any substances form. And so we saw a few of that stuff from these different reactions. And so next up, we're looking at number 4, and I eliminated the explain part here. What might you assume about these structures of these different materials, different metals based on their activities? And we're going off with a simple explanation here that these structures are built differently. The structure for magnesium is different from zinc, and explain how you reach your conclusion. What evidence do we have? The conclusion and evidence comes from what we saw. Our conclusion is these structures are built differently. The evidence that we have is the reactivity. Magnesium really reacted. Copper did not at all. Zinc was somewhere in between, so that tells us that it might have an in between. It might act like an in between magnesium and copper. That's what we're just rolling with. This is a working definition, and we're gonna add on to this as time goes on. We're gonna clarify this as time goes on. Last up, we had different metals, different alkali metals, lithium, sodium, potassium, and they react differently when placed in water. Or they react very similarly when placed in water. And what might you assume about these metals? And what we came to the conclusion that something is being added to these metals as they go down their column. Now, some of you guys were exposed to this site, ptable.com. We're able to identify, oh, lithium's here, sodium is here, potassium's here. These are all alkali metals. These are all alkali metals, and so we're including that in our explanation here. That's fine. More to the point, in the next topic here, these notes on subatomic particles, that's when we get into more of the reasoning behind why these things happen. Why did magnesium react? Why does sodium and potassium react violently in water? And so let's talk about the notes on subatomic particles. We finished this off in week 1. And so what we're looking at was a few different things. The notes on subatomic particles are essentially a history lesson. And so through hundreds of years of science, we have developed an understanding of the atom and the things that make up the atom. And so the first thing that we brought up was a cathode ray tube and that experiment that goes along with it. So for the cathode ray tube, it's essentially a negative end or a positive end and a negative end. You shoot some electricity into the positive end and it will shoot a beam of what we call electrons now towards the negative end. And if you take a magnet to it, that beam will either go up or down based on that magnet. And so if you take the positive end of the magnet and stick it to the beam here, the beam will be drawn towards the magnet. And that tells us that this beam is negatively charged, which in turn tells us that electrons are negatively charged. We're calling this electrons now. And so that kind of gives us understanding of the start of the atom, that there's a positive charge in there, there's a negative charge in there. And so we're moving on to how they experimented with this kind of idea. And there's something like, and this is something I brought up next, which is the idea of these different particles. So in class, we had a little riddle, and the riddle is you have 3 cookies, each of them emitting one type of particle or ray. And you have to eat one of the cookies, you got to put one of the cookies in your pocket, and you got to put one in a lead box. And so we have these particles, alpha particles, beta particles, gamma rays. And just briefly going over them, alpha particles, you can see them here on the slide, are pretty big. Gamma rays are very fast, very narrow, a lot of energy. And beta rays, kind of big, but overall, it's still pretty slow. It's pretty manageable. So if we look at the images here, alpha particles could be blocked by a simple sheet of paper. Beta particles, you're gonna need a little bit thicker material there, maybe like a sheet of like metal. And then gamma rays, you need several feet of concrete, maybe a couple layers of lead, and even still, some of that gamma ray might still go through. And so these are the subatomic particles chemists way back when used to explore the makeup of your atoms, right? We shot some particles at an atom and we see what kind of happens. How do they affect each other? And so if we had to decide which cookie to eat, we're going to eat the gamma ray cookie. Reason being, whether or not you put it in the box, in your pocket, or in your mouth, the gamma ray is going to go through it. And so you might as well just eat the gamma ray cookie. Which one do you put in your pocket? You put the alpha particle cookie in your pocket because those alpha particles will be blocked by your pants. It's thick enough where those particles probably can't go through them. Finally, you put the beta particles in the lead box because you need a little bit of a stronger material to stop a beta particle. And so we have that answer right there. Now, I took a poll, and we have this understanding of science as being brand new and at the same time kind of settled. And so people tend to like run with different topics that they find in science and just roll with it. And one of the things that most annoy me is the word quantum. A lot of people, when they hear quantum, and this is true in your classes, they hear quantum and they're like, oh, okay, we're talking about science fiction now. But that's not true at all. Quantum actually does mean something. It doesn't mean you could shrink down to the size of, I don't know, a bear, a tardigrade bear, and enter the quantum realm. That's not a thing. In actuality, quantum is just how we measure light. A unit of light is called a quantum. And so we took a poll in class, and we look at these different models, and this is just the history of our atom in brief. Most of us are familiar with the nuclear model, where we have a positive nucleus and several electrons running around the nucleus. Some of us are familiar with the planetary model and the quantum model, and very, very few of us are familiar with the plum pudding model. And that was very interesting to see that. Someone mentioned in the reflections, we were talking about British food, and plum pudding is definitely a British food. I don't quite understand that. But yes, we were talking about these different models, and most of us were familiar with the nuclear models. And we want to see how they're different from each other. And if we look at them, we see that, okay, early on, our particles are literally just that. They're particles with no charges in them. There's nothing really differentiating them from anything. It's just a block. But we go deeper. We do the cathode ray experiment, and we know that, oh, okay, these particles actually have charges. And so let's just say the electrons are all scattered throughout. And there's a positive charge in there as well, also scattered throughout. And so that's how we start off. But then we do some more experiments. We do the gold foil experiment. In the gold foil experiment, we shot alpha particles, these big blocky things. We shot alpha particles at some gold foil. Go here and actually show you this out. Shot alpha particles and some gold foil. And if the plum pudding model was going to be correct, those particles should have just gone straight through. But they didn't. The particles somewhat got deflected. They got reflected right back at you. And so this is groundbreaking because it tells us that while most of the atom is empty space, right? We have a lot of empty space here. There is a solid core in the middle and several electrons that get scattered off to the side. And so now we have this model. And as time builds up, we get more and more different types of models until we get to the quantum model, which is essentially a combination of all of these. So like the first model, it's a solid sphere. It's a sphere. Like the second model, there's a positive center here. Like the third model, we have electrons kind of in orbit around the nucleus, but we have instead regions now. So electrons are more likely to be found in that darker blue region and less likely to be found the farther you go out. And so we kind of combined aspects of each of these different models into our final quantum model. Now, this is something we kind of finished off really quickly. But if we went through the vocab, we would talk about these different words here. Electrons. Electrons are negatively charged. They orbit a nucleus. And something about them is that they always will match the number of protons because your overall atom has to be neutrally charged. There's no charge on an overall atom. And so protons, which are positively charged, and electrons, which are negatively charged, have to kind of cancel out. Next up, we have a nucleus, which is where most of the mass is in your atom. And the nucleus has both protons and neutrons. Going through with this, we have what a proton is, which is something that's positively charged. And again, will match the number of electrons. And we have neutrons, which exist in the nucleus and are kind of like the glue. They hold the thing together. They're like a spacer because they have no real charge attached to them. They're overall neutral. We didn't talk about this, but we're going out here. And so when it comes to this, atoms have to have a neutral charge. Therefore, protons and electrons must be the same. So if an atom has 4 protons, it must also have 4 electrons. And therefore, if we're talking about the properties of these elements, If we look at a periodic table, number 1, number 2, number 3, number 4, this is the number of protons that exist inside of our atom, and it's the number of protons and electrons that determine the properties of an element. All right, so this has been a recap for the first week. Not too much as far as the chemistry went. That's really going to happen in this week 2 video that's coming up. Something I want to point out is that something new we're doing this semester are these weekly reflections. You should every Friday or that weekend write a reflection about what you learned or saw interesting or didn't know about a reflection, and turn it in. Use this document to guide you, but it's only just that. It's just a guide. Go ahead and take a look here. Let that load in. You just answer these questions. What do you want to know about? Anything else that comes to mind? How was the week in terms of like you as a student were you paying attention? Were you actively listening? Were you getting distracted? What is something you found interesting? Just use that to guide you. And you're going to want to do one every week. And they'll be graded at the grading periods. So that takes us to the end of week 1. We'll come back with week 2 very soon. All right, so I hope this recap video was an enjoyable experience. Otherwise, have a great rest of your day. Bye-bye.